Hello everyone. Today we have got this Edexcel IGCSE Photo Pure Math past paper from January 2012, and this is paper 1, question 8. It is a alpha beta question, so about the sum and product of the roots in a quadratic equation, and it is 13 marks long. So it deals with these two equations. The equation x squared plus mx plus 15 is 0 has roots alpha and beta, and the equation x squared plus hx plus k equals 0 has roots alpha over beta and beta over alpha. And these alpha and beta refers to the roots of the original equation. Anyway, we can see initially that both of these equations have no additional coefficient for the x squared. And what you know, if something, for any equation x squared plus bx plus c equals 0, where there's no a because a is 1, then this equation will be equal to, in terms of the sum and product of its roots, x squared minus alpha plus beta x plus alpha beta. And so if I zoom in a bit here, you may notice that this gives us the information, for example, that m is going to be minus alpha plus beta, 15 is alpha beta, and so on and so forth. The same applies to this with the roots alpha over beta and beta over alpha. So in this case, the first question being write down the value of k. K is going to be the product of the two roots, alpha and beta, alpha over beta and beta over alpha. And of course, when you multiply these two together, the two betas cancel out and the two alphas cancel out, so you're just left with 1. That's why this is a question that says write down, and it's only 1 mark instead of find or anything like that. It's a pure accuracy question. You just need to write down that k is equal to 1. So secondly, find an expression for h in terms of m. Okay, so h is going to be this alpha over beta plus beta over alpha. But the thing is, it's going to be quite the tedious task to get h directly in terms of m. So what I plan to do is to first find h in terms of alpha and beta and see how we can manipulate the value of m, that is m being minus alpha plus beta, to give us the same expression as we have the expression for h in terms of alpha and beta. So this will become clearer as I do it, and what I mean by finding first the expression in terms of alpha and beta to begin with, because after I do that, I will bring m into the question. But before that, I'm ignoring the part about m, just going after h in terms of alpha and beta. So I'll specify this here to the examiner that that's what I'm trying to do. So first, finding h in terms of alpha and beta. So of course we have alpha over beta and beta over alpha. So we know that it's going to be the negative sum of the roots is what h is. So h is equal to minus alpha over beta plus beta over alpha. And of course we could get this minus sign here, because we want to remove the minus sign here to make it more easy to work with. So minus h is equal to alpha over beta plus beta over alpha. And what we could do now, since this is not in really a form that we can work easily with to get our terms of m, because we know m is negative alpha plus beta, so we can write that m is equal to minus alpha plus beta to begin with, or that minus m is equal to alpha plus beta. And we have this expression here. We're going to add up the fractions and get them into like terms by multiplying both the numerator and denominator of this by alpha, and then both the numerator and denominator of this by beta, so that the denominator is both alpha times beta. So minus h is alpha squared over alpha beta plus beta squared over alpha beta. Now, of course, you add these up and you'll get minus h is equal to alpha squared plus beta squared over alpha beta. Now, one thing that we can do with this expression is that you may recall from doing similar questions like these that to get just alpha squared plus beta squared, you need to get alpha plus beta squared minus 2 alpha beta. And the thing is, we need to work with this alpha beta here by itself on the denominator. And what we can actually do, because they give us the constant term in this equation, the 15 here, we can say that firstly, minus h is going to be equal to alpha plus beta squared minus 2 alpha beta over alpha beta. And this in fact is if you replace, or rather we'll just write down here, substituting alpha beta as 15, then we get minus h is equal to alpha plus beta squared minus 30 over 15. And alpha plus beta, as you know, is negative m, so if we substitute alpha plus beta as negative m, this turns to minus h is equal to minus m squared minus 30. And the thing is, we can put this denominator over 15 separately, because 30 over 15 is going to cancel out to a perfect 2. And of course, minus m squared, since it's a negative squared, you will get a positive number. So minus h will be equal to m squared over 15 minus 2. And of course, to remove the negative sign on this part here, we multiply both sides by negative 1. So h is equal to, well, and a nice trick to know is that if you have some a minus b that you multiply by negative 1, it will automatically become b minus a. Just like think about the fact that one number becomes bigger than the other, like the difference between them becomes negative because they switch places. So h is equal to 2 minus m squared over 15. Right, so to recap what we've done here, we first found it in terms of a and b, a squared plus b squared over ab, and we recognized, firstly, that alpha beta is a value given to us in the fact that it's 15, and secondly, that this alpha squared plus beta squared is something we can work with in the sense that it's a common sort of the sum of the squares of the roots. Alpha squared plus beta squared is something we know will be probably this expression here, because we can expand it out to this, or this is another form of saying this, and this makes use of alpha plus beta. So that's why we would want to do something like that. Anyway, once we have this form, we make the two substitutions of the values we know in order to get m into the equation here. And once we do have m into the equation, we simplify it into our final form, which is 2 minus m squared over 15. So we are done with this part, finding an expression for h in terms of m. And since the answer is just the expression, not an equation, we're going to box this as our answer, 2 minus m squared over 15. Now, thirdly, question C. Given that beta is 2 alpha plus 1, find the two possible values of a, of alpha, that is. So I think that since there is no hence, and because alpha is just the root of this equation, I don't think we're going to be looking at this equation for this part of the question. It seems to me that we will only need to look at this equation because we'll get x squared plus, x squared plus minus alpha plus beta, and of course we can substitute beta in terms of alpha, plus alpha times beta is equal to 0, and x squared plus hx plus k equals 0. So in actual fact, we might need this to be the case. Anyway, let's just throw some numbers at it and see what happens. So I'm not actually sure how to approach this question, so the first thing I will try is substituting values into this equation here and seeing how far we get. Like, the good thing to do if you are stuck on a problem and it's in multiple parts, you just find one aspect of the problem that you're going to attack, and partway through doing the problem you might make a realization that will lead you to solve the rest of the problem. So we have x squared plus mx plus 15 equals 0, and I've just had a realization. So we know that k is 1, we can ignore this and just write 1 instead. So what I think we can do is we substitute m as our, we substitute 8 as our 2 minus m squared over 15. And since we know this is going to be equal to alpha over 2 alpha plus 1, or the negative of this, this might enable us to go somewhere. Anyway, so x squared plus mx plus 15 is 0, and we know that x squared minus 3 alpha x, because it's going to be the sum of the two roots will be 3 alpha plus 1. So minus 3 alpha x minus x plus 15 is 0. So that's one equation. And secondly, we have two minus m squared over 15, which is this thing here. Or well, we know okay, after thinking about this a bit more, I have concluded that while it may have been useful to look into these equations, what we are actually looking for all along was just the use of this 15 here, because it's alpha times beta, and since we know beta is some expression of alpha, by multiplying together we'll probably get a quadratic that is equal to 15, and we can solve that for the values of alpha. So using the knowledge that 15 is equal to alpha beta, and we sub in beta as 2 alpha plus 1, then we'll get 15 is equal to alpha times 2 alpha plus 1, which is equal to 2 alpha squared plus alpha. And of course we can move this 15 to the other side, so we'll say 2 alpha squared plus alpha minus 15 is equal to 0 if we subtract 15 from both sides and swap them over across the equal sign. And then what could we do here? This may or may not be factorable. Since the coefficient of the alpha squared term is more than 1, or is not equal to 1, then we'll do a factoring by grouping, which is that we have our, we're going to split this plus 1 alpha into two numbers. So I can see that AB is negative 30 and A plus B is positive 1 in terms of the two numbers A and B that we're going to split this 1 into. And I can already see that it's going to be negative 5 and 6, which multiply to negative 30. So 2 alpha squared plus 6 alpha, we'll put 6 here because it's the one that's divisible by 2, minus 5 alpha minus 15 is equal to 0. And then we'll just write what we're doing, so factoring by grouping. And then that highest common factor in here is 2 alpha, so 2 alpha times alpha plus 3 minus 5 times alpha plus 3 is 0. And then the highest common factor here is alpha plus 3, so alpha plus 3 times 2 alpha minus 5 is equal to 0. And now we have our easy to solve quadratic with these two terms here. So yes, in actual fact, we just needed to look at the product of the roots being equal to 15 to get our possible values of alpha as negative 3 and, well, 2 alpha minus 5 is 0. That would just lead us to positive 5 over 2. Alright, so like I said earlier, it may not seem like I did any attacking of this problem by writing stuff down, but like, trust that as long as you try a problem and then you keep thinking about your approach to it, you eventually find what information you need to look at in order to solve it. Don't ever stonewall yourself on a problem to the point where that you are so focused on getting through or grinding through your one solution that you may not be able to see a more obvious solution in front of you. Alright, so finally it says, hence find the two possible values of m. So clearly we have got some m here that we want to find out. Now, we know that from our previous exploration that m is going to be the sum of alpha and beta, so m is going to be negative alpha plus beta by the sum of roots principle for the quadratic equation. So given that beta is 2 alpha plus 1, we are going to say that m is negative 3 alpha plus 1, or m is minus 3 alpha minus 1. So at this point it's just easy casework. So case 1 that we determined was that alpha would be negative 3. So you might want to use a ruler for this, but I'm just making it clear that I'm going through it case by case. So m is minus 3 times minus 3 minus 1 equals positive 9 minus 1 equals 8. And secondly, case 2. What I mean by two cases is that we found two solutions for possible values of alpha. So if m is based off the value of alpha in the fact that it's 3 alpha plus 1, if there are two possible values of alpha, there will be one possible value of m corresponding with each value of alpha that you found. So case 2 would be that alpha is positive 5 over 2. Or that m is equal to negative 3 multiplied by, well, substituting alpha in for positive 5 over 2 plus 1. And of course, negative 3 multiplied by positive 5 over 2 is going to give you a fraction as well. So m will be equal to negative 15 over 2 plus 1, which would be equal to negative 13 over 2. And that's our second answer for m. Alright, to reiterate this journey of problem solving that we've gone through here, finding an expression for h in terms of m, initially a daunting task, but you get it by first finding the expression in terms of alpha and beta, then using your knowledge of the common substitution that alpha squared plus beta squared goes to this in order to figure out the whole problem. And secondly, finding the two possible values of alpha given that beta is 2 alpha plus 1. It was quite tricky to figure out what actually to do but not to do it, because I was distracted by the fact that we have the m here, which is 2 alpha plus 1 or 3 alpha plus 1, but it's really something I should have ignored, because given that we are finding m from our values of alpha in the next part of the question, I doubt that we would be finding values of alpha from m, and m wasn't even a number we knew. So clearly the last part was to go to this value we know right here. And so there we just got a quadratic, we factored it, we solved it, we find two values of alpha and two values of m based off two values of alpha with the expression for m in terms of alpha that we found, which was m is minus 3 alpha minus 1. Oh, yeah, I've made a mistake. So this is not a plus sign. This is not meant to be a plus sign. It's minus 3 alpha minus 1, which we did write correctly here, but this is not the case in our working down here. M is minus 15 over 2 minus 1, which is equal to minus 17 over 2. Right. Make sure you always check your work, otherwise you will find a mistake like this. So you do the casebook here, you make clear which case is which so that the examiner knows which case he's marking. And that's about all I have to say for this question. So thank you for watching.